In this video, we are going to cover the topic of dividing polynomials. First, we will cover how to do that with long division. Then we will finish with synthetic division. Consider 347 divided by 7. To solve this, I would write it like this, 347 there, and then I would ask, what can I multiply 7 by to get me as close to 347 as I can? Or I could ask, how many times can 7 fit into 347? Well, it's just shy of 50, so I'm going to write 49 up here. And 7 times 49 is 343. So if I subtract these two together, I get a remainder of 4. So this tells me that 347 divided by 7 is equal to 49 plus 4 over 7. And we're done. Now notice we have gone from a number 347 divided by 7 in which the fraction that is greater than 1 to a situation where we have a fraction 4 over 7 which is less than 1. And that's how we know to stop. Now consider this polynomial, and we wish to divide it by this divisor here. How would we do it? Well, again, let's set it up as before. Next, we will ask, what can I multiply x by to get me close to 4x squared? And in this case, I can multiply by 4x. And that gives me 4x squared. But if I multiply x by 4x, I also have to multiply minus 2 by 4x. And that would give me minus 8x. I then subtract. So that gives me 0. 12 minus 8 is 20x. And I carry down the 6. Again, I would ask, what do I need to multiply x by to get me close to 20x? In this case, it would be 20. Again, multiplying the minus 2 by 20 gives me minus 40. And then subtracting gives me 0 and 46. This means that we can rewrite 4x squared plus 12x plus 6 divided by x minus 2 as being equal to 4x plus 20 plus 46 over x minus 2. Now notice, just like in the case of 347 divided by 7, this equation, the dividend had a degree higher than the divisor. So we knew to stop when we reached a situation where the remainder had a degree less than the divisor. The dividend had a degree x to the power of 2, whereas the divisor had an x to the power of 1. In this case, there is no x term, and there's an x degree 1 in the divisor. Here is some terminology. 46 here, that is the remainder. The x minus 2 here, that is the divisor. The 4x squared plus 12x plus 6, that is called the dividend. And the 4x squared plus 20, that is called the quotient. To generalize this, we can rewrite this as p of x is equal to d of x times q of x plus r of x, where q of x is the quotient, d of x is the divisor, r of x is the remainder, and p of x is the polynomial. Let's try that example again, but instead let's apply synthetic division. We wanted to divide this polynomial with this divisor, and we had set it up like this. With synthetic division instead, we're going to set it up instead like this. The divisor is of the form x minus c. So we will write the c value here, or in this case 2. We will write a box like this, and then we will write the coefficients of the polynomial in the box. Next, we will write the first coefficient here, 4, and then we will take the 2 and multiply it by the 4 to give us 8, and then we will add these two numbers together to give us 20. Then we will take 2 and multiply it by 20 to give us a number here, which is 40. We will add the 40 to 6 to give us 46. In this case, the 4 and the 20 gives us the coefficients for the quotient polynomial. Synthetic division works when the divisor is of the form x minus c, because in this case we had x minus 2. But of course we could also have had x plus 2, because we could have written x plus 2 as x minus minus 2. In general, when we have a polynomial of the form and we want to divide it by we just have to follow this procedure. We then take c and multiply it by bn minus 1 to give us this number. Which gives us bn minus 2. We then multiply it by c. Multiplying c by bn minus 3. Where r is the remainder. And the quotient if the polynomial p of x is divided by the divisor x minus c, then the remainder is p evaluated at c. For example, in this case, p of x is equal to 4x squared plus 12x plus 6, and p evaluated at 2 gives us 46, which was the remainder we found earlier. Here's a proof. It's very short. Lastly, if x minus c is a factor of p of x, then c is a 0. For example, p of x is equal to x squared minus 4. X minus 2 is a factor of p of x. Thus, 2 is a 0. Here is another example. I will do the long division here and the synthetic division over here. And now the synthetic division. And one more example. And now for the synthetic. There we go.